Welcome to Veda Vartha. So today we discuss about three topics, that is variance, bias and outlier. These three topics plays an important role or significant role in model's output. Let's start with outlier. I will start with a basic example that I took in our last video in mean median mode for statistics. That is, suppose we are having 8-10 students, out of which 8 students are placed in a company having average placement of 4 to 5 lakh, and 2 students placed in a company like Microsoft or Google having placement of 50 to 60 lakh. If we calculate an average, it will come around 23 lakh. So this is an average what college is showing in the next year, so that who are applying in our college can see that their average placement is 23 lakh. But that is not true. That is not the correct output. This is because of these two, 50 and 60 lakh students, that is acting as an outlier. That means 8 are having correct and similar outputs, 4 lakh, 5 lakh, 4.5 lakh, 4.75 lakh, but 2 are having 50 to 60 lakh. That means these are acting as an outlier in our output, that is model's output. Let's see the book's definition. An outlier is a data point that significantly differs from other points in a data set. We just saw that 50 and 60 lakh are completely different from the output. Now, second is biasness. As the name refers, it's a model tendency to make consistent error in prediction due to oversimplification. In simple words, biasness is, for example, you are thinking that the output will come around 5 or 6, but your output is coming 10, 9 or 11. That means there is a biasness in the output. Output is not correct. Third one is variance. We will understand this with a simple example. For example, 4 boys are running in a race. Second one is 2 meters away from the first. Third one is 4 meters away from the second. Fourth one is 10 meters away from the first. The distance between them is known as variance. How it is used in model? If model is predicting 5 outputs, if model is predicting that the amount of water in the kettle, it is predicting like 10 milliliter or 10 liter, 20 liter, 30 liter or 40 liter. The water difference between them is the variance. How we are using? Let's take a simple example. First one is for outlier. For example, there is one equation of a line y is equal to mx plus c. We are predicting that how many points are closer to that line. You can see all the points are closer to the line in the first example, and only one point that is at 6035 that is completely different, right? That is an outlier. In the second example, all the fish are moving in the left direction. Only single fish is moving in the right direction. That is acting as an outlier in the fish data set. Second one, to understand variance and biasness, we will take the example of dart game. In our dart game, we used to hit the target. Let's take that example only. In the first one, for example, I'm trying to hit the target. My target, that is small circle, that the middle one, but I'm unable to hit the target. I'm targeting at around 4, 18 and 1. I keep targeting at 4, 18 and 1 and I'm unable to hit the target. Now at this time, biasness is too much because I am unable to hit closer to the target. So the biasness in the output is too much, but variance is low. Why variance is low? Variance is the distance between the point output, distance between the or difference between the output. I tried to hit 4 times, so the difference between my 4 output is very less, so my variance is low, but biasness is too much, as output or result what I want to predict, that is too far. That means in the first one, biasness is too much and variance is less. In the second one, I try to hit the target, and by luck all the 4 targets are close to my output, what I'm trying to predict. That means biasness is very low but variance is high, as all the target are away from each other. All the 4 outputs are away from each other. That means high variance. So what we expect in our model is that our model will have low bias as well as low variance. This example, you can see first one, all points are away from the target. So that means biasness is too much but variance is less, as all the outputs are closer to each other. That means variance is less but biasness is high. In the second one, variance is also high at the outputs which are coming away from each other. Similarly, biasness is high as they are away from the target. In the third one, outside 3 that are closer to the outside circle are acting as outliers, and the above 2 which are closer to the target are the actual point. That means biasness is somehow less but variance is too much at the as the outputs are away from each other. In the fourth one, that is what the expected or what everyone wants that the model should predict, like low variance and low bias. All the 5 points are closer to the target as well as they are closer to each other. That means there is no outlier. We can understand that we should have a model, or we should train a model on that data set that is having less outliers, or we should remove the outliers to reduce the variance as well as to reduce the bias. That is called bias variance trade-off also. In the next video, I am planning to make a Python series starting from just calculations, addition, subtraction, list, tuples, arrays, then moving to applications of Python, that is NumPy, then pandas, then visualization, that is Seaborn. After that, we will move to machine learning models and so on. We'll make a playlist for this and update you soon. Thank you for watching and subscribe if you haven't.